Have you ever wondered what would happen if you took a trip to one of the most mysterious and, let's be honest, terrifying objects in the entire universe? Well, today we're going to take that trip. Okay, so let's really dive into this. We're going to strap in for a first-person journey right into the cosmic abyss, all based on what our best science says would actually happen. Forget what you've seen in the movies. This is the real deal. All right, so first things first, what exactly is our destination? You know, a black hole is an empty space. It's pretty much the opposite. I want you to imagine taking a star, one that's way, way bigger than our own sun, and crushing it, squashing it, all the way down into a space that's only a few kilometers across. It's that insane density that creates a gravitational pull so powerful that once you cross a certain line, there is absolutely no coming back. And what's wild is that the scale of these things can be totally deceptive. You might be picturing these cosmic monsters that are just unimaginably huge, but some of them pack the mass of several suns into a space smaller than a city. It's that density, not necessarily the size, that makes them so incredibly powerful. So, which one do we pick for our journey? Well, they come in all sorts of sizes, and for us to even survive the initial approach, we need to aim for a really big one. A supermassive black hole, kind of like Sagittarius A star, which is right at the center of our own galaxy. Now, why a big one? Well, paradoxically, it's actually safer, at first anyway. See, the tidal forces at the edge of a small black hole would shred you to pieces before you even got close. But with a supermassive one, the pull is more spread out, more even, which lets us cross the boundary all in one piece. So, we're getting closer now. We're approaching that boundary. It's called the event horizon. And this isn't some physical wall in space. It's an invisible line in space-time itself. It is quite literally the point of no return. There's this fantastic analogy one physicist used to describe it. He said, imagine the gravity of the black hole is pulling space itself inwards, just like a river flowing towards a waterfall. Right at the event horizon, that river of space is flowing at the speed of light. So even if you're a particle of light, literally the fastest thing in the universe, you can't swim fast enough to escape a current that's already moving at your absolute top speed. You're just swept away. Okay, so we've turned off our imaginary rocket engines and we're just floating. What does it actually feel like to cross this ultimate point of no return? You'd probably expect alarms, some big dramatic moment, right? Nope, it feels like absolutely nothing. No warning signs, no jolts, nothing. From your perspective, you just drift across this invisible line in total, peaceful freefall. And this is where things get truly bizarre, thanks to Einstein's theory of relativity. For you, the trip across feels normal, but for someone watching you from a safe distance, your journey looks completely different. To them, they'd see you start to slow down as you get closer to the horizon. Your image would seem to stretch, get redder and dimmer, until you appear to just freeze in time, forever imprinted on the edge of the black hole. So while you experience your fall in just a few seconds, they see it take an eternity. Two totally different realities. So we're inside the event horizon now. There's no turning back. And this is where things start to get, well, let's just say uncomfortable. The laws of physics are about to get personal in the most violent way you can possibly imagine. The legendary physicist Stephen Hawking, he came up with the perfect and frankly completely horrifying term for what happens next. He said you'd be subjected to a process he called spaghettification. And this isn't just a simple stretch. As you fall feet first towards the center, the gravitational pull on your feet becomes exponentially stronger than the pull on your head. So you're being pulled longer and longer and longer, but at the exact same time, all the forces around you are squeezing you in from the sides, making you thinner and thinner. This process just keeps going until your body isn't a body anymore. It's just a thin, long stream of individual atoms, all racing towards the center. So that stream of atoms that used to be you, it's on a one-way trip to the black hole's core, to something called the singularity. But what is the singularity, really? This is where our understanding of physics just completely breaks down. Inside the event horizon, space and time basically swap roles. Now, what does that mean? It means the singularity isn't a place you can try to fly away from. It's an event in your future. Moving towards it is as inevitable as us moving into tomorrow. It's not a location, it's the end of time itself. Think about it. You just can't avoid it. Every single path, every possible direction you could possibly take in space now only leads to the singularity. Trying to turn your spaceship around and fly away from it is like trying to run away from next Tuesday.
It's not a place you can escape. It is a moment you are destined to meet. So, according to Einstein's theory, your journey ends right there at the singularity, crushed completely out of existence. Your story is over. But, and this is a huge but, there's a massive conflict right at the heart of modern physics that suggests the story is actually far, far weirder, and that your end is really the beginning of a profound cosmic puzzle. This is the famous black hole information paradox. You see, on one hand, Einstein's theory of relativity says that everything about you, the unique arrangement of your atoms, your memories, your experiences, all of that information is utterly destroyed, gone, forever. But on the other hand, a core rule of quantum mechanics says that information can never truly be destroyed. It's a fundamental law of the universe. So you have this massive contradiction between our two best theories of how the universe works. Which one is right? While Stephen Hawking gave us the first major clue, he figured out that, because of some strange quantum effects right at the edge, black holes aren't completely black after all. They actually emit a very, very faint glow, which we now call Hawking radiation. And this means they are slowly losing mass and energy, and over unimaginable timescales, we're talking trillions and trillions of years, they will eventually just evaporate and disappear completely. So what happens to all the information of everything that ever fell inside? The latest thinking is that this radiation that leaks out, it's not random static, it's not meaningless. Instead, all the information about everything that ever fell into that black hole, and that includes you, is slowly, painstakingly encoded onto that escaping radiation. So in a way, a kind of cosmic ghost of you escapes. The information that made you, isn't destroyed. It's broadcast back out into the universe, just scrambled across eons of time. So what started as a one-way trip to oblivion has turned into something so much stranger. It's a journey that literally rewrites the nature of reality itself. You know, black holes are the ultimate cosmic laboratories. They force our greatest scientific theories to their absolute breaking points. And they show us that the universe is far more mysterious and interconnected than we ever imagined. It just makes you wonder, right? What else is out there, just waiting to challenge everything we think we know?